Hello, in this video we're going to be looking into thermistors. Thermistors are basically a resistor whereby the temperature can change the resistance of that particular component. So it's a very interesting component. The representation of that looks like this. You will have to learn this symbol. This is what we will be using in the circuits that we'll be looking in this particular video. So thermistors are nothing except they are a type of resistors, and what makes it very different to a standard resistor is the type of material that the thermistor is made up of. So thermistors are made up of semiconductors. So it's a semiconductor. Semiconductors are neither a conductor, which is a good conductor, or they are not even an insulator. So they're somewhere in between. So they've got enough electrons, but these electrons are not free to move and they carry current. Now, the quality of a semiconductor is that if you give it a little bit of heat energy, these electrons will start to be released. So on heating a semiconductor, more free electrons are now readily released. Therefore, semiconductors' conductivity will increase with the increase in temperature. Now, we did say that a thermistor is made up of a semiconductor. So if I say that the thermistor's conductivity increases with temperature, then that would be correct. So thermistor's current flow will increase if you increase the temperature. That means when you increase the temperature, the current flow increases, and if the current flow is increasing, therefore we can say that the resistance is decreasing. So resistance of a thermistor would decrease when you increase the temperature, and this is a very important and interesting characteristic of a thermistor. So in order to summarize, semiconductors' conductivity will increase when you heat because the electrons are readily released. But you can only increase the temperature to a certain extent. After that, all the electrons that were meant to be released are released and the current flow will plateau. But overall, when you look at the summary, greater the temperature, less is the resistance. So to summarize, you've got these two things. So on this side, you've got what is happening at high temperature. On this side, you've got what is happening at low temperature. You would be asked in your exam to plot the graph between resistance and temperature. And sometimes remembering this graph kind of helps you to relate to the difference between what's happening at high temperature and what's happening at lower temperature. So as the temperature increases this way, you can see that the value of the resistance is decreasing. So the R decreases as T increases. So this is where the temperature is high, so very hot, and when it is cold, this is what the resistance is very high. And based on this, you've got very interesting applications. So when you also look at the IV characteristic, now in most of your textbooks, you will see the IV characteristics given for filament bulb, for a diode, and for a resistor. You won't see quite often the IV characteristic given for a thermistor, but you would need to know this. So if you look at it, you've got the current and voltage graph. You can see how it's behaving initially, but as you increase the temperature, the current flow has increased a lot. So that's the type of curve you will get for thermistor, whereas if you had a curve for filament lamp, it is the reverse of that. So you would get a graph like this, where it plateaus as the temperature increases, whereas in this case, it's the other way around, where as the temperature increases, the current flow increases. So it's quite important to understand that key fact, that as you increase the temperature, resistance decreases, therefore the current flow increases. So let's take a look at one of the applications where you've got a system, a circuit like this. Now, this is an interesting circuit that's usually found in heating systems. So if you think about here, so if I've got a cell here, so I've got The cell will have a particular voltage here, so let's call it V total. Now you would recognize this symbol. This is for thermistor. Thermistor is attached to, we could call this a bulb. You could have a heater here. It's important to note that these two are in parallel. So as the temperature, if you increase the temperature, as the temperature increases, we know that the semiconductor will get hot and therefore the current flow increases, therefore the resistance will decrease. As the resistance decreases, less energy is needed to push the current through. Therefore, you can say the potential difference across this component decreases. So the potential difference decreases. So we know V is equal to IR. If resistance decreases, the potential difference decreases. Now, potential difference in a parallel circuit is the same. So whatever is the potential difference of the thermistor, the bulb will have the same potential difference. So we've got quite a low voltage here. So voltage is decreased. Now, because of that, you will find that the bulb will not light up, or the current will not, or the bulb will not light up, or if it's a heater, the heater will not work strongly. So when the temperature is high, you don't want the bulb to light up and warm if you're heating up, let's say a fish tank, or if you're heating a pet tank, so you don't want that to light up. So when the temperature increases, this component does not work. Whereas if the temperature is low, that's when you want the bulb to light up and heat the fish tank, or if it's an animal container, or if it's a room heater, you want a room heater to start. So when the temperature is low, resistance is high. Because the resistance is high, more energy is needed to push the electron through. Therefore, the potential difference is high. So the potential difference across the component is high, and that means across the heater, the potential difference is high, and therefore, if it's a bulb, it will light up quite brightly. So this will be lighting up brightly, and your heater will work strongly, therefore heating up the room. And that's because you've connected the thermistor across the heater in a parallel circuit. But what happens if the thermistor is connected to something which is in parallel? So if you are in parallel, you know that whatever is the voltage here, it is shared. But what about if the system is connected? So if I put a component here, let's call it a fan here, and if I'm connecting it to a thermistor like this. So that's your thermistor, that's your fan, that's the current flow. Now, if the temperature is high, then the resistance would be low. That means the amount of energy needed to push the electron through this thermistor is low. So if my resistance is low, potential difference is low. Now these two components are connected in series. Because they're connected in series, we know that V total in series is equal to V1 plus V2. So if the overall total is Vt, then if this one is low, if V1 is quite low, that means that V2 is high. That means that the electrons passing through the fan are pushed with a greater electrical energy, and therefore the fan works quite strongly. So the fan moves very faster, and the fan will kick in and it will cool the system down. So this sort of setup you would use when you want the fan to start when the temperature is high. So you could arrange this type of a circuit in any any type of machine where you want to cool the system down as the temperature increases. So it could be in your phone, it could be in your computer system. So depending on whether you want the system to work in a heating or cooling way, you can arrange the thermistor either in series or in parallel. So based on the applications, you can, based on the type of circuit, you can have a different variety of applications. So thermistor can act as a fire alarm. They can be used in home heating system. They can maintain the temperature in fish tanks, in reptile tanks, in incubators. They can be used as a digital thermometer. They can be used to cool the laptop down. So there are a variety of ways in which you can use a thermistor. And in the next series of videos, we'll start to look into some of the application-based exam questions, and we're also going to solve some problems based on the data that would be provided to you in the exams. So thank you for listening to this video.